All right, good afternoon, everyone. Today we are going to look at volumes of revolution. So we are going to rotate about the x-axis and about the y-axis. So let's just start with a simple example here. If this is your f of x and you want to rotate this shaded shape here about the x-axis. So when you rotate here, it sweeps a volume, a three-dimensional volume, which is like that here. So this is rotating about the x-axis. And the formula for rotating about the x-axis would be pi. Here you would have limits for x here. Okay, so these limits for x here. And you would have y squared dx here. Dx because we are rotating about the x-axis. The other one we're going to do is rotating about the y-axis. All right, so you have got a shape here. Let's call that again f of x. And you're rotating about the y-axis. So it's this volume here. When you rotate, it sweeps a three-dimensional shape like that here. The volume about the y-axis is pi y0. So these are limits for y that you would have. So these limits for y, you would have, of course, dy, and here you would have x squared. So these are the two important formula that you need to remember. Vx, volume about the x, Vy, volume about the y. Mainly you are rotating 360 degrees. All right. You are not given these formulas in your formula booklet. So we want to look at examples on how to use these formulas here. Right. Our first formula here, we are given you are given a shape which is drawn. So you're given y equal x to the power 4, and you want to find the volume obtained when you do rotate about the x-axis. So your volume of rotation about the x-axis, you write it down, limits for x, y squared dx here. Okay, so you need to substitute for the limits. So this is pi. Now for x, you see our limits are from 0 to 2 here. Y squared. Now we are given y equal x to the power of 4. We need to substitute in y squared here. So we need to square either side. So we're going to square each side. So this is going to be y squared equal, remember laws of indices, these multiply, x to the power 8. So this is what you are going to come here to substitute. All right. So, and then dx. Now, simple integration here. This gives x to the power of 9 over 9, and then your limits 0 to 2. Remember how to substitute the limits. We are going to go the upper limit, so 2 to the power of 9 over 9, minus, we subtract the lower limit, 0 to the power of 9 over 9. All right. And you see that if you do that on your calculator, you get 512 over 9 pi. So this would be your exact volume when you rotate this about the x-axis. Right. Our last example is, let's see what happens if you rotate about the y-axis. So there is our example here. You want to rotate this here about the y-axis, so our shape goes this side. Our formula Vy is pi, limits for y, as usual, x squared dy. All right. And again, like we did, we need to substitute for x squared. This is important. So you go to the formula given and you want to make x squared the subject. So I take 1 the other side. I have 2x squared. I divide by 2. I've got half y minus 1 equal x squared. So I've made x squared the subject. So when I go on the other side, that's what I substitute. So I'm going to substitute pi. My limits for y are from 2 to 5. And then I've got half y minus 1. I've substituted for x squared dy. Right. It will be easy for me to integrate if the half goes out. So this is half pi. And then I'm just left with integrating y minus 1 dy. Right. So this is half pi. And if I integrate y, I get y squared over 2. If I integrate 1, I get y. And then my limits 2 to 5. Remember, so this is pi over 2. Remember, we do upper limit. So this is 5 squared over 2 minus 5. This is upper limit. We subtract the lower limit, 2 squared over 2 minus 2. And again, if you simplify this on your calculator, you get 15 over 4 pi. Right. So this is how you use the formulas for volume of when you rotate about the x. Remember, you need to substitute the x squared if it's about the x. If it's about the y, you also need, sorry, if it's about the y, you substitute the x squared. If it's about the x, you need to substitute the y squared. All right.